Hello, welcome to your dividing fractions homework help video. So today we're going to be going over quite a few problems on the front side, and then we'll be reviewing how to set up all of the problems on the back side so that you know how to solve them. So here we go, let's get started. So the very first thing that we need to review is the diamond method. So the diamond method is something that I learned this year that I now teach dividing fractions with, and so if you watched the notes video and it talks about keep, change, flip, you can use that method as well. But the diamond method is a little bit easier, I think, to go over. So we're going to use that today on this worksheet. So the diamond method, we start with the top numerator of the first fraction, and we're going to multiply it. I know it's weird because it's a dividing fractions problem, but just trust me here. We're going to do 10 times 3. And then we're going to draw a line up here, and that's going to become our numerator of our answer. So 10 times 3 is 30. And we have 27 times 2, and we're going to put that down below. So I don't know what 27 times 2 is, so I'm going to come out here, and I'm just going to do it quickly. 2 times 7 is 14, carry the 1. 2 times 2 is 4, plus 1 is 5. So we've got 30 over 54. Okay, now we've got to make sure that this is in simplest form, right? Because that's the instructions that were given to us. We've got to write our answer in simplest form. So I'm going to try and divide a number into each of these to simplify it. So I know that 30, the factors of 30 are 10 and 3, 5 and 6. So I'm just going to try 3. So 30 divided by 3 would give me 10. 54 divided by 3. Let's see if that works. 3 can go into 5 one time. And that gives us 2 left over. Bring down the 4. Oh, excellent. So that gives me 18. Now, if we do that, this ends up turning into 10 over 18. But I now know that a number can go into 10 over 18, or 10 and 18 as well. So I know that 2 can go into 10, and I know 2 can go into 18. So we're left with 5 over 9. And that's the simplest answer that it can be. Okay. So if you get here and you're stuck, just know that you have to just make sure you find the number that can go into both, and then keep going down until you get to the smallest answer. Okay, so there's number 1. Number 3, I'm going to skip some. I'm not going to do all of them just for the sake of the length of the video. Okay, so for number 3, we're going to do the diamond method. Now, a trick for the diamond method as well, if we take these numbers that are across from each other, and if we find a number that can go into both, then we can actually simplify it a little bit more. Now, if that's too confusing to you, then just do the diamond method like normal, and then you'll have to simplify at the very end. Okay, so let's find a number that can go into 25 and into 15. I know that 5 can go into both, so I'm going to do 25 divided by 5. That gives me 5. And then 15 divided by 5 gives me 3. Okay, so those are now simplified. Now we're going to simplify these two. We've got 18 and 8. So I know that I think 2 is probably the biggest number. So 18 divided by 2 is 9. And 8 divided by 2 is 4. So now we have some simplified fractions. Okay? And all we did was just simplify the top and the bottom, right? So now we're going to do 9 times 3, which gives us 27, and 5 times 4, which gives us 20. Okay, so now, we have a bigger number on the top than the bottom. So in that case, we're going to have to simplify this by doing long division. So we're going to come up here and we're going to put the top number in the division box, and then the bottom number on the outside. I know that 20 can go into 27 one time. That leaves 7 left over. And so we have 1 whole with 7/20 left over. So 27/20ths and 1 7/20ths is the same thing. So that would be the most simple answer. Okay, all right, let's move to number 5. Now we've got some mixed numbers. When we have mixed numbers, we have to change them into improper fractions in order to divide it properly. So in order to do that, we're going to do all around the world. So we're going to do 2 times 3, which is 6, plus 1, which is 7. So I'm going to rewrite my fraction now. So we have 7 over 2. And we're going to do the same thing here. We're going to do 4 times 2, which is 8. 8 plus 1, which is 9. We're going to put it over 4. Okay, now we have a problem that looks like this, so we're just going to do diamond method. Okay. So we can simplify these two, but let's just go ahead and do diamond method like normal, especially if we don't want to confuse you at all. So here we go. We've got 7 times 4, which is 28 on the top. 2 times 9, which is 18 on the bottom. Let's simplify it a little bit more. So because we have an improper fraction now, we can either do this, divide, or we can simplify it a little bit more and then divide. So let's just go straight to divide. So we have 28, I'm going to do it out here, divided by 18. 18 can go into 28 only once, okay, and that leaves us 10 left over. So we have 1 and 10/18 as our answer. Oh, but wait, 10/18 can be simplified a little bit. 10/18 can be simplified. So if we divide both by 2, we get 5/9. So this one really is 1 and 5/9. That's the most simple answer. Okay. Okay, let's go to the word problem. So number 7 says a bag contains 36 cups of flour. How many loaves of bread can be made if each loaf takes 5 1/3 cup? Okay, so very first we know that we're going to divide because we have 36 cups of flour, and if each loaf takes 5 1/3 cups, we're going to divide 36 by 5 1/3. So let's go ahead and write that right out. That's the first step. 36 over 1, I'm changing that into a fraction just by putting it over 1. And then we've got 5 1/3. Now I've got to change this into a mixed number, or an improper fraction. So I'm going to do 3 times 5, which is 15, plus 1, which is 16. So our whole new problem is 36 over 1 divided by 16 over 3. Okay. Okay, next up we've got to do diamond method because we're dividing here. So we're going to do 36 times 3. I'm going to come over here and do it. 3 times 6 is 18, carry the 1. 3 times 3 is 9, plus 1 is 10. Okay, so the top number is 108. Bottom number is 1 times 16, which would just be 16. Now we're going to do 108 divided by 16. Can get a little messy. Okay, so 16 into 108. I don't really know how many times. I think I'm going to try to do, let's do 16 times 4 just to see if that gives us close. I think it's going to probably be more than that. So we've got 4 times 6, which is 24. 4 times 1 is 4 plus 2, which is 6. Okay, yeah, it definitely can go bigger than that. Let's try doubling that. Let's go 16 times 8 and see. 8 times 6 is 48. Carry the 4. 8 times 1 is 8 plus 4, which is 12. Ooh, we're just a little bit over, so I'm thinking it will probably go in 7 times. 16 times 7 is 4, so 7 times 6 is 42, carry the 4. 7 times 1 is 7 plus 4 is 11. Really, we're still over. Okay, so we've got to do 16 times 6 now. 6 times 6 is 36, carry the 3, 6 times 1 is 6, plus 3 is 9. Okay, there we go. So it goes in 6 times. 6 times 16, we had 96. And we're going to subtract. We've got 8 minus 6, which is 2. We got to borrow. That will be 1. Okay, so here is the deal. If we are talking about how many loaves of bread can be made, we know that 6 whole loaves can be made. Now, 6 whole loaves, and then we have 12/16 left over. So it says, is there any flour left over? If so, how much? So we know that 12/16 cups of flour are left over. Okay? Alright. Alright, now number 9 and 10, I am not going to do. These are just kind of challenges. So if you can't get these, please don't stress. These are actually a little bit trickier. If you do want to do them, you have to do change these all into improper fractions, and then you're going to multiply first to get an answer, and then you're going to divide by that one. This one is GEMDAS, so we have parentheses, which means we have to follow, we have to do that first. So we divide those, then you multiply it by that. Okay, those are just kind of challenges. You're never really going to see anything like this on tests or anything. It's just kind of like a little challenge that we added to our homework. All right. Okay, so that's the front side. Remember, this is just an extension activity. It's totally optional. You do not have to do the extension activities. Okay, but we're going to go ahead and flip over to the reflecting back. And the reflecting back, all it is just review of anything at all that we've reviewed or learned in math so far. So it will always just be a quick little review. The reflecting back should be like the easiest side, I would say. So here we go. It says evaluate the expression, write the answer in simplest form. Now, one thing about the reflecting back is that I'm just going to help you set up the problem. I'm not going to do them out like I did the front. Okay. So when it says we need to evaluate the expression, all that means is to solve. Okay. Now the dot here, remember the dot just means to multiply. So we're not using the diamond method on this because it's multiplication. All you're going to do is you can go straight across. Okay, so you can multiply straight across and get your answer, but you need to make it into simplest form, which means you got to find a number that will be divided by the top and the bottom. Okay. Another way to do it is that you can cross cancel, like I showed you in class. So if we have 3 and 9, 3 and 9 can be simplified, right? So 3 can be divided by 3, which gives us 1. 9 divided by 3 gives us 3. So we got 2 times 1, which is 2. 3 times 5, which is 15. So that would be the simplest answer there. So that's how you do the cross canceling. Okay. So I did actually do that one for you, so you're welcome. Okay. Number 2, we've got evaluate the expression, so that just means to solve, and then we're going to write our answer in simplest form. The very first thing you need to do is change these into improper fractions by doing the around the world. Once you get those fractions, you're going to do the same thing up here. You can either do cross cancel, or you can go straight across and then simplify. Okay. Number 3, we've got a division problem. Remember that this fraction line, it just means to divide. So we're going to take 7,954 and we're going to put it in our division box, and we're going to divide it by 181. Okay, I'm going to get you started on this one. So first things first, remember how in math class I told you that the math gods aren't going to whisper how many times 181 can go into this number. So we're first going to start off, we're not going into all 4, we're only going to go to the 3. So we're trying to find out how many times 181 can go into 795. So I'm going to do 181 times, let's just say 6, and see if we can get close to 795. 6 times 1 is 6. 6 times 8 is 48. Carry the 4. 6 times 1 is 6 plus 4, which is, okay. So clearly it can go a little bit less, right? Because we're trying to get to these 3 numbers. So it can go a little bit less. So let's try doing 4. I was just going to erase it, but we're going to just come down here. We're going to go 4 times. So 4 times 1 is 4. 4 times 8 is 32. Carry the 3. 4 times 1 is 4 plus 3, which is 7. Ooh, that looks good to me. So it goes in 4 times. We're going to put it over the 5 because that's the last number that we divided it into, right? So we just have that 4 left over. So we've got 4 times 181, which is 724. We're going to subtract 5 minus 4 is 1, 9 minus 2 is 7, and then we're going to bring down our 4. Okay, we've got, so that kind of gives you a head start. You're going to do 181 into 714 now. We know that timesing it by 4 will be too big. So you'll want to times it by 3, and then it looks like you're going to get a remainder on this one. Alright, the next one is evaluate the expression. Remember that the dot just means to multiply, so we're just going to set up our multiplication problem like this and multiply straight out. Okay. Okay, it says, which of the following numbers is a perfect square? Remember, when we talk about a perfect square, the characteristics of a square is that we have the same length on this side and this side. So if we have a perfect square of 4, that means that there's 2 on this side and 2 on this side. See that? So same thing with a perfect square of 4, when we have 4 squares in there. I just did the same exact square, my bad. So let's say we do this. We have 3, 1, 2, 3, 1, 2, 3. So the perfect square would be 9, right? So we need to determine which one of these numbers is a perfect square. Which number of these has a doubles fact that works, right? What times what gives us 100? What times what gives us 48? Now if it's a doubles fact, then it works. It's a perfect square. If it's not a perfect square, right? Because if we had a square with, let's say 2, but then we have 1, 2, 3, 4, 1, 2, right? That's just a rectangle. That's not an actual square. Okay. All right, find the value of the power. Remember that the base is the number that's being repeated, and then the exponent tells us how many times to repeat it. So we've got 5 times 5 times 5 times 5. So then you're going to actually solve that out, and that will be the value of the power. Okay? Okay, what operation should you perform first when you evaluate this expression? So this, we're talking about GEMDAS. So I'm going to write this over here to help you remember. We've got GEMDAS. So the very first step would be for grouping. So you need to find the one that is 4 minus 2. And you're going to circle it, and that will be the right answer. Okay, then the last step is use GEMDAS to evaluate the expression. So you're going to use those same steps to find the answer for that problem. Okay. All right, that is your homework help video. I hope this helped. If you have any other questions, just come tomorrow and ask them, and I would be happy to answer. Thank you.